Hello everyone and welcome to another chemistry video. In this video we are going to discuss empirical formula. First off, I want us to look at the difference between the molecular formula and the empirical formula of a substance. Now the empirical formula is essentially the simplified version of the molecular formula. Now the molecular formula shows all the atoms and how many atoms are actually there in a single molecule of a certain compound, and then the empirical formula will just be the simplified version of the molecular formula. So if you look at compounds such as benzene C6H6, it can actually be simplified to just CH. The same would apply to glucose C6H12O6. It can be simplified to CH2O. However, when you're dealing with certain compounds such as water, the molecular formula and the empirical formula are exactly the same, simply because you cannot simplify further the molecular compound. It's already in its most simplest state. Now, like I said, the empirical formula is the simplest formula a compound can have, and it can be calculated from either percentages or masses, these percentages being percentage by mass, obviously. And provided you are provided with the relative molecular mass, you can actually find the molecular formula from the empirical formula. Okay, let's look at an example of how you do this. So in this example, you have to calculate the empirical formula of a compound containing 40% carbon, 6.67% hydrogen, and 53.3% oxygen. And you are also told to calculate the molecular formula if the relative molecular mass equals 180. So the format that you are going to use is this one: symbol, percentage, moles, mole ratio, then the empirical formula. Whenever you get this type of question, always write down this format. You need to get the format or memorize the format or know it by heart so that you can use it. It will guide you. This is your guideline. So here at percentage, it can either be percentage if the question has given you values in terms of percentage, or you can write grams if you have been given values in terms of grams. It doesn't matter whether it's percentage or grams, you will still use the exact same step. The only difference is that in one case it's percentage and in the other case it is grams. So you write out the chemical symbols as they are given. So you are given carbon first, then hydrogen, then oxygen. After that, you write the percentages that you were given. Carbon is 40, hydrogen is 6.67, oxygen is 53.3. And then you have to calculate the number of moles. How do you do this? You simply divide these percentages by the atomic masses of each element. The atomic mass for carbon is 12, for hydrogen is 1, and for oxygen is 16. Once you divide out, you would get the number of moles. And then once you have the number of moles, you can move on to calculate the mole ratio. How do you calculate the mole ratio? You simply divide the number of moles of each element with the smallest number of moles that you got from the previous step. So the smallest number here is 3.33 3. So you're going to divide all these numbers by 3.33, and then you're going to get these numbers. Now, at this point, I guess it is very important to note that you have to actually round off the numbers below to whole numbers. Now, you know the usual rounding rules. If it is 5 and above, round up. If it is below 5, round down. That technically doesn't apply here because, or let me just say, we're going to alter it a bit. Here we are going to say if it is above 5, then round up. If it is below 5, round down. If it is exactly 5, then multiply everything by 2. Please try to remember that rule. And then, of course, now that you have your mole ratio, you can just simply plug that next to the symbols, and that is your empirical formula. However, we are not done. The question asked you to calculate or to determine the molecular formula, and you've been given the relative molecular mass. So how you're going to do that is simple. We know that our empirical formula is C1H2O1. By the way, we usually just leave out the ones. So you're going to say the relative molecular mass of N of the empirical formula is equals to the relative atomic mass. The relative molecular mass. Okay, then you are going to substitute each chemical symbol with the actual atomic mass, and then you are going to multiply that out. You would get 30N is equals to 180. You make N the subject of the formula, work that out, and you would get N being equal to 6. When you are done, then you are going to say, okay, if you have 6, or if your N is equals to 6, then you are going to multiply your empirical formula by 6, and you would get C6H12O6. If you want to know if you got this correct, if you simplify the molecular formula, it should bring you back to the empirical formula. So I have not attached an exercise for this video. It will be provided separately. Remember to submit and stay home, stay safe. Wash your hands regularly, sanitize, and do your part in the fight against coronavirus.